Welcome back, Honors Algebra 2. We are going to continue on with the study guide doing our trig identities. So I highly recommend if you guys don't have these identities kind of memorized at this point, make flashcards. Like even though, this is going to be a little bit different, I still recommend you try to memorize them because it will make the process easier. You'll be able to see how to solve it easier if you know kind of what's going on. So that's kind of my recommendation for this section. I think we're going to do 11 through 16. Yeah, we're going to do 11 through 16. Okay, so we're going to start with 11. So the first thing we want to do is make sure all of my angle measures are the same. So I can change either one of these. I can change tangent 40 to be cotangent 50, or I can change cotangent 50 to be tangent 40. So I'm going to just change the top one. So we're going to change tangent 40. We know the complementary angle of 40 degrees is 50. 90 minus, nope, I wanted to put 90 minus 40. I was going to try and cross it out. And then you know what? We have white out. 90 minus 40 equals 50. So we know, okay, complements. So I can use my complementary angles theorem and convert it then first to cotangent 50 over, and then we're not going to change this one, cotangent 50. So the first thing we always want to do, and that's what I did, is we want to get the same angle measure. That should be, if there are angle measures, that should always be your first step. And you're always going to be doing that by using the complementary angles theorem. Complementary. And so what I did there was now I can basically just simplify. Cotangent 50 over cotangent 50, anything divided by itself gets me 1. And so I'm left with 1. Now, let's say I had changed the denominator, and I changed the denominator to be tangent 40. Well, I'd still get the same thing. Tangent 40 over tangent 40 is still 1. Okay, so let's move to 12. We don't have to worry about the same angle measures because 28 and this doesn't even have a trig function. But what we do have to start thinking about is our Pythagorean identities. So I think whenever I see a square is always an indicator. Think Pythagorean identities. So I don't actually have the ones with cosecant memorized. I have just the ones with sine squared theta plus cosine squared theta equals 1 memorized. And then from there, I will in my head, I know that cosecant is 1 over sine. So that means if I divide everything through by sine squared theta, I'm going to get 1 plus cosine over sine is cotangent squared theta. I have that memorized. And 1 over sine is cosecant squared theta. So what I'm actually going to do here, I'm going to use substitution. And I'm going to plug in, I know that cosecant squared theta is the same as 1 plus cotangent squared theta. So I'm going to actually plug in cosecant squared 28. I'm going to use substitution and substitute in this. And I'm going to, instead of cosecant squared 28, I'm going to put 1 plus cotangent squared 28. And then minus 1. And then from there, okay, I can simplify. So 1 plus cotangent squared 28 minus 1, the 1's cancel. 1 minus 1 is 0. and I'm just left with cotangent squared 28. And that would be your final answer. And again, I know like identities sometimes can be tricky. So if you guys need help with these, please come to office hours. I'm super happy to help you guys, happy to help in any way. So come by there. Okay, so 13, we first want to make sure, okay, all of these need to be the same angle measure. So I have 3 of the 32, so I'm just going to change the 2 of the 58. So we know, okay, is 90 minus 58, does that get me 32? And it does. So for both of these, we can change both of those first. That's going to be kind of my first thing I want to deal with. Because right now, this looks like a lot. Sorry, I'm trying to get there we go. This looks like a lot, but once we like take it just step by step, it will make it a lot easier. So we're going to keep cotangent 32 the same. Sine 58, we're going to rewrite it using the complementary angles theorem. So I'm going to rewrite it as cosine 32. And then sine 32 is going to stay the same. Plus tangent 32. And then tangent 58, we're going to rewrite as cotangent 32. So all I did was I first got the same angle measures. By using the complementary angle theorem. Okay, so from there, the next thing I always want to do, I don't have any squared terms in there, so I don't have to think about the Pythagorean identities. But what I do want to do is I want to convert everything in terms of sine and cosine. So cotangent, I know cotangent is cosine 32 over sine 32. And then this is already in terms of cosine and sine. And then tangent, I know, is sine 32 over cosine 32. And then cotangent 32 is cosine 32 over sine 32. And so then so what I did there, just to kind of reiterate, I changed everything, like all terms into terms of sine and cosine. So they are in terms of sine and cosine. Okay, so cosine 32 over sine 32 minus cosine 32 over sine 32. This is the same thing minus the same thing. And we know, okay, this is going to result, anything minus itself is going to result to get me 0. And then sine 32 over cosine 32 times cosine 32. These are going to cancel. Cosine and cosine, top and bottom, sine and sine. Anything divided by itself simplifies to be 1. 0 plus 1 is 1. Okay, let's move on to 14. So 14, cosine squared 70 minus 1 plus cosine squared 20. So first thing I want to do is rewrite them so they have the same angle measure. I'm going to rewrite cosine squared 70 in terms of sine. So we know these are complementary angles. 90 minus 70 we know is 20. Connect that a little bit better. And so cosine squared 70 can be rewritten as sine squared 20 and that is my first step. Again, we're using the complementary angles theorem. And I could have changed cosine. Like that would have gotten you the same answer in the end. So whatever you guys want to change is totally fine. Now I'm going to do actually a little rearranging because what I recognize is, okay, there are squared terms and I'm going to rearrange this so it's sine squared 20 plus cosine squared 20 minus 1. So all I did was just rearrange my terms. So it wasn't anything crazy there. But now what I recognize is I have squares. And so that tells me I'm going to use the Pythagorean identity. Well, I know, remember the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Well, I have sine squared 20 plus cosine squared 20, so I can substitute that in. I know this entire thing equals 1. So what this ends up to be is 1 minus 1. And 1 minus 1 is 0. And that is your final answer. Okay, so sine x cosine x over 1 minus sine squared x. So for one thing, just like to tell you, so theta and x can basically be interchangeable, so it doesn't matter. Just like when you're writing your answer, be consistent with the problem is saying. So if the problem had theta in it, you'd use theta. If the problem has x in it, use x. Okay, so first thing, they don't have any angle measures, so we don't have to worry about the complementary angles theorem. But what I do recognize is the squared. So that's telling me I'm going to use my Pythagorean identity. So that's my first thought. I think, okay, my Pythagorean identity is cosine squared theta plus sine squared theta equals 1. You could use x, it doesn't matter. And then I'm thinking, well, what about 1 minus sine squared x? Well, if I move this over, if I subtract sine squared theta from both sides, I get that cosine squared theta equals 1 minus sine squared theta. And then I can use substitution. If 1 minus sine squared theta equals cosine squared theta, I can substitute that in here. And I'm going to rewrite it in terms with x, so we stay consistent with the problem. And so that would be cosine squared x. Well, if I have a cosine on top and a cosine on bottom, and this is 2 cosines, I can actually cancel out the one on top and one of the ones on the bottom. It's like having x over x squared. So the one on top would cancel, the 2 on bottom, one would cancel, one would stay. And so I'd be left with then sine x over cosine x. And we know sine x over cosine x can simplify even further to be tangent x. And that is my final answer for that one. So we first just used the Pythagorean identities. And rearranged it. I canceled, and then this to that is using the quotient identities. Knowing that, okay, sine over cosine is tangent, cosine over sine simplifies to be cotangent. Okay, so the last one we're going to do with identities is 16. Okay, so this one seems a lot, and this is a little bit different than what we've done before. But what I am going to do is I'm going to first, we have these parentheses. I'm actually going to just distribute to cotangent to both of those. So it's going to be cotangent x times secant x minus cotangent x to cosine x. So my first step, all I did was distribute. And then all of my angle measures are the same. So what I'm going to do is I'm just going to keep them, like I don't have to worry about complementary angles theorem. So the only step that I do care about is rewriting everything in terms of sine and cosine. So cotangent x, we know, is cosine x over sine x. And I know secant x is 1 over cosine x. Cotangent x, same thing as cosine x over sine x, and then cosine x over 1. Okay, so then I can start to cancel things if they have anything in common. Cosine x and cosine x can cancel. And I'm left with 1 over sine x. And then cosine x times cosine x can actually become cosine squared x over sine x. So all I did from here to here is I wrote in terms of sine and cosine, and then here I just canceled and combined like terms. Now what I'm going to do is I'm going to write it as one fraction. I'm going to squeeze it in down here, 1 cosine squared x over sine x, and then to go further, I'm going to move up here. Now I see I have a Pythagorean identity, so I have to think about what is my Pythagorean identity. So we have sine squared theta plus cosine squared theta equals 1, but I have 1 minus. So it's similar to the one that I had over here. If I like the prior one, if I subtract 1 from both, or cosine from both sides, I have sine squared theta equals 1 minus cosine squared theta. And so I can use substitution here. If 1 minus cosine squared x is equal to sine squared theta, or sine squared x, I can rewrite that. So instead of writing 1 minus cosine squared x, I write sine squared x and then over sine x. And then what happens is it's now like x squared over x. So this one can cancel and this one can cancel. And in reality, I'm just left with sine x. And that's my final one. These are the type of problems that I live for. I love these types of problems. I think they're so fun. That was definitely more of a challenging one for you guys. But I really just want you guys to get this exposure. So when you guys see it in honors pre-calc or regular pre-calc or whatever you guys are going to take, you have that exposure and you're comfortable with it. So that's that. That's all of our identity problems. So I'll pick up on the last video doing 17 and 18. So that's it for this one. I'll see you guys later. Go get a snack.